The EMM on V models has a built-in Start Assist circuit, or SAC, that uses a step-up converter to boost battery voltage to 30 volts. This helps to actuate the injectors, which normally operate on 55 volts, to ensure they provide enough fuel to start the engine. The 55-volt circuit should show approximately 30 volts when the key is turned on. Once the engine starts, the circuit should jump to about 55 volts. You can verify the SAC is operating correctly by observing the number 1 LED on the EMM when you turn the start switch on. The LED will light when the system voltage reaches 30 volts. Inline models do not have a Start Assist circuit, but the number 1 LED will still light at 30 volts. Starting in 2005, the EMMs on V models have the ability to communicate with I-command gauges. In 2008, this was extended to inline models 40 horsepower and above. For more information, refer to Essentials, Rigging and Propeller Selection. Our engineers have made ETEC so quiet, they introduced a new problem. The operator might try to start it when it's already running. So the EMM on V models features a safeguard to prevent the starter from engaging when the engine's already running. Unlike older outboards, the yellow-red lead does not energize the starter solenoid. It informs the EMM that the start switch has been activated. The EMM, in turn, makes sure the engine isn't running before it activates the starter solenoid by providing a ground. Evinrude Etec models are the first direct injection engines that don't require a battery. That's why rope starting is possible. When you pull on the rope, a rapid chain of events begins. First, the stator powers up the EMM, which activates the fuel pump. At the same time, the capacitor is storing energy to fire an injector and spark plug. In less than half a revolution, the EMM determines the crankshaft position. Then it injects fuel into the correct cylinder and fires the spark plug at the right time. Once the engine fires, the EMM quickly adjusts the injection and ignition as the engine rapidly accelerates to idle speed. When starting, the EMM monitors the voltage available and does not attempt to fire the injectors or spark plugs until the capacitor has stored sufficient energy. If there isn't enough energy at the end of the first pull, the capacitor stores that energy. The capacitor then combines it with the energy from the second pull to start the engine. Models below 40 horsepower do not have an external capacitor. Instead, they have capacitors inside the EMM. The EMM is powered by the stator, which provides 55 volts. All ETEC models use the same tachometer setting, 6 pulse. There's a generous amount of charging current available at all engine speeds. The EMM converts the AC electricity generated by the stator to DC. The white line shows the electrical power required to operate the engine, power accessories, and charge the battery. This demand increases with RPM. Connecting all of the stator's windings in series, as shown by the yellow line, will generate power quickly at low RPM, enough to rope start these models. However, as RPM increases, the coils become saturated, and they can't generate much additional current. Connecting the windings in parallel, as shown by the blue line, decreases the resistance of the windings. This increases the current or amperage available at higher RPM. But when the windings are connected in parallel, the stator cannot provide the power needed at low RPM. Our engineers solved this problem by connecting the stator windings in series for starting and low RPM operation, and in parallel for higher RPM. The EMM controls the configuration of the windings and regulates the voltage. Let's look at how the EMM does this. We'll look at the 40 through 90 models, but the principles are the same for all ETECs. The EMM uses silicon-controlled rectifiers, or SCRs, as tiny electric switches. The gate controls the SCR. When voltage is applied to the gate, current flows through the SCR. When starting or running at low RPM, the SCRs are enabled, connecting the 3 windings in series to maximize voltage output.